Now we're looking at the area of 2D figures. And with the area of 2D figures, we're looking at the space that covers the region. And so here, when we're looking at this, we're not going to end up with an answer that comes with inches or centimeters or units alone, because if we're measuring that, then we end up having just a line, just like how this is a line where we can say it is 5 inches or 5 centimeters or 5 miles. um, we're not measuring a line, we're measuring the whole area, the region. And so that becomes what we can actually create into square amounts. And so here, for example, we can see even one square, we can think of another square, think of another square, and that becomes what we're measuring is how many squares cover the whole region. Now, sometimes we end up not having full squares, so there are different ways that we can help figure these out without having to always try and count up squares. Here, let's start with an actual square. So here we have a square, and because we're looking at the different side lanes, this could be 5, that could be 5. This could be 7, and if this is 7, this has to be 7. If this is 28, this has to be 28. And so whichever we have, they're going to be the same. So we could just use the letter S to represent the sides. Since it's the letter S on both of the sides here, that means that we have S for this side, S for this side. Notice the little lines here represent that they're all the same. And so here, S just represents one side length, and since they're all the same, S has to be the side lengths of all the other sides. To find the area of this one then, we are really just taking S and multiplying it S times. S times S is the exact same thing as saying S squared. So this right here is telling me I'm going to make a square out of the S, and here we go. S is being squared. Next, let's take a look over here now at the rectangle. With our rectangle, we can think of this as the length times the width. We can think of it as a base times the height. To differentiate a little bit, let's go ahead and talk about length and width instead, because you do hear these terms all the time. So here, area, similar to the square, we just multiply one side times the other adjacent side. We're going to do the exact same thing, because here I can think that L, you can see that happening, a total of W times going up this side here. So here, a rectangle really is just L, W, or length times width. When you see the letters next to each other, really what we're doing is multiplying them. Can't do the same thing with numbers, because if we have the numbers right next to each other, it looks like we just created a much larger number. So be careful with that. Let's go down here now to a parallelogram. Our parallelogram, when we've figured before that we have a base and we could find a height for our parallelogram. Do you remember that our base and our height have to be perpendicular to each other? So we could choose any line to use as a base. This top line could be our base, this side line could be our base. The only thing is that whatever we choose as our base, the height has to be perpendicular to the base. So here, this is much nicer one to use. It's nice and flat. The top one's nice and easy to use because it's nice and flat. So we can just find a height that's perpendicular to the base, and it reaches the opposite side perfectly. Okay? Now, we've decomposed, we've rearranged our parallelograms, we've cut them up, we've moved them around. That's what it means to compose, or to decompose and to rearrange. And so here we notice that if we actually even just put it right in this place, because it is a parallelogram, it does fit perfectly, and we can just think about this as being our base, slide over a bit, and the same height. And so all we're doing for parallelograms, remember, is to multiply the base times the height, just like we were looking at a rectangle, and we end up getting our area for any parallelogram. Let's take a look now back up here to our friendly triangle. Our triangles also have a base and a height. Same as our parallelogram, we could use any side as long as the height is perpendicular. So here, this is a nice one because again, we could easily see where the base would be compared to the height. If this is your base, again, your height has to go from the base all the way to the opposite vertex this time because we're going to the point, and when we get to the vertex, that would be what we represent as our height. Or you could always even start it here as long as we get perpendicular line that goes all the way to where the height is. Um, all right, and so now we can think about doing base times height for a triangle. The only difference now is that we're not going to have the whole thing. Just like here, this is the base times the height. But we do know that any parallelogram that is split in half, or that we can take half, actually becomes a triangle. And so here, this is the exact same idea. We're really not just taking the base times the height. It is basically that parallelogram split in half. And so we can think about multiplying it by 1/2, take half of the base times the height, or dividing the base and height by 2. So here, base times height times 1/2, or we can again think about it as base times height divided by 2.